In Lesson 5, Sasha and Keoni developed the equation y equals x squared divided by 4 times p. This equation represents any parabola with its vertex at the origin. The p in the denominator of the equation represents the distance between the focus and the vertex. In this lesson, the goal is to figure out what effect changing the value of p in this equation has on the graph of a parabola. Sasha and Keoni will begin making sense of this goal by graphing a parabola that has a p-value of 1/4. They use both algebraic substitution and geometric information. At the end of this episode, they will make a prediction regarding what happens to the graph of the parabola when p increases to 1/2.
Your goal today is going to be to figure out the effect of changing the value of p in your general equation y equals x squared divided by 4p on the graph of the parabola. Let's just write the general equation for any parabola that goes to the origin on that sheet, maybe at the top.
Y equals x squared 4p.
And today you're going to work with 3 specific parabolas that have increasing values for p. So I'm going to have you start with p equals 1/4. So could you write p equals 1/4 on that sheet? And then I want you and Sasha to pick 2 other values, both that are bigger than 1/4.
1/2?
Not 1.
1/2 and 1?
Sure. Okay, so we're going to start by having you graph the parabola that has a p-value of 1/4. Before you get started, what is its equation? What is the equation of that parabola when p is 1/4?
It would be y equals x squared over 1.
Why?
Because you plug in your p.
Yeah. So y equals x squared.
Can you write that down?
In this lesson, Sasha and Keoni will graph 3 parabolas and see what happens each time the p-value increases. They have decided to work with p equals 1/4 for the first parabola, and then increase the p-value to 1/2, and then finally to 1. To graph the parabola with a p-value of 1/4, they start with the general equation for any parabola with its vertex at the origin and substitute 1/4 for p. Because 4 multiplied by 1/4 is 1, the denominator is 1. Then any number divided by 1 is that number, so the equation for the parabola with p equals 1/4 is y equals x squared. Next, Sasha and Keoni graph the parabola by substituting different values for x into this equation to find the corresponding y values.
Okay, do you want to say like when our x is 1, right? What's our y, right? Just plug in, right? Do you like that?
Yeah.
Do you get what I'm saying?
Yeah, you're good.
Yeah? Okay. We're going to say our x is 1, so then 1 squared is still 1. It's going to be 1, 1.
So you found a point on the parabola.
Yes.
How did you find it?
We we plugged in 1 for x.
Okay.
So when x equals 1, y equals 1. When p equals 1/4. And then, wait, 1, 2? Sure. Do you want 3? Okay. And then we're going to have 2, so then when x equals 2, it would be 2 squared, which is
4.
Yay! We got 2, and then it's going to go up to 4. And
Sasha and Keoni are very good at using algebraic substitution to find points on the graph. For example, when x is 2, they replace the x in the equation with 2 and determine that y is 2 squared, which is 4. Thus, there's a point on the parabola with the coordinates x equals 2 and y equals 4. Next, Sasha and Keoni shift to using geometric information to plot additional points on the parabola, but they are not sure where the focus is for this parabola.
Now, before you plot any more points by using the equation, by plugging in, you have a method now.
mm-hmm.
Can you find a point without plugging into that equation? Just by using what you know already about the geometry? of parabolas?
Right there.
Why?
Because it's equal distance from our focus and our directrix.
Where's the focus?
Yikes. Well,
We can plug in the origin because that's what we used our equation for. Like our equation only works when it's on the origin.
Okay. Can you use another colored pen and get the focus and the directrix in there?
All you, buddy.
okay, it works. So what's our focus?
Tangerine.
You want our focus to be 1, right?
Sure.
Yeah. Okay. So our focus.
Why is it 1?
Why is it 1?
I don't know.
But what was your thinking?
Because that's like a general place to put it. Well, that's what I thought.
General place to put it.
Yeah.
A nice value to work on.
Yeah.
If the focus were there, what would the p-value be?
1.
And what p-value are we working with this particular problem?
1/4.
1/4.
Can you adjust your focus then?
Yes. So like right here, right? No.
Well, our P is 1/4, so your P, yeah,
Yeah.
right?
I don't know.
I agree with you, buddy.
Are you sure?
Yeah,
You agree?
sure.
Why do you agree?
I don't know.
Right there.
It sounds like you're not sure.
Also, when P is 1/4, I just thought that the focus would be here now because here's our 1.
Okay.
And then here's half of 1.
Okay.
And I'm just trying to do half of that half.
So the distance is the distance from the origin to the focus 1/4 of a unit? 1/4 of 1?
1/4 of 1.
Okay. So why don't you label which is the focus since there's 3 red dots there, just so we don't get
I tried to
confused.
undo it. Oh, I did undo it. Okay.
And what would be the coordinates from that point?
0, 1, 4, or
Go ahead
1/4.
and write that down.
Or 0.25.
Let's do 1/4.
Just 1/4. Okay. You can't even see that.
And where would the directrix be?
Down the line.
Right here. Yeah.
And why is that?
Because our point has to be equal distance from our focus and our directrix. And if this is one of our points, it has to be equal distance from both of them.
Okay.
Sasha and Keoni figured out something important. When P equals 1/4, then the focus is 1/4 of 1 unit from the vertex, and the directrix is also 1/4 of 1 unit from the vertex. Next, Sasha and Keoni use this geometric information to locate another point on the parabola.
Now, can you use this information, the focus and the directrix, to find another point on the parabola without plugging directly into the equation?
When it's like on the same line as the focus, right?
So like right, oh, different color. Like right there. You think? No. Because that's not equal distance from our focus and our directrix. See?
You sure?
Yeah, because this is... Oh, never mind.
It is, right?
I was just kidding.
You sure?
It was a joke.
Okay.
Okay, yeah.
Yeah, right there.
Right there.
Little red dot.
Right here.
What is the
We know.
what are the coordinates for that point?
1/4 and 1/4.
But it's like on the 1/2 line.
Well, no, because
do you think,
that's
Sasha?
1. That's
You know, because of, like our dot is on this line, and this line is half.
so right. So 1/2 and 1/4. Yeah.
That's where our dot is. You and that undo button.
I know, we're best friends. 1/2 and 1/4.
Now, what are a couple different ways you could check that point?
Well, I don't know. This is what we had problems with solving the other one.
You're doing great. So using the definition, does it fit the definition?
Yes.
Because it's the equal distance from the focus and the directrix.
What is that distance from the point to the focus?
The distance from our point to our focus is
One
one
half.
half.
What's the distance from that point to the directrix?
One half.
Why is it 1/2?
Because this is 1/4 and that's 1/4,
Okay,
so
cool.
the whole thing is 1/4.
Does it also fit into your equation? Like I temporarily relieved you of being able to use the equation y equals x squared. If you plug it in, will it work?
Well, let's see. So
Plug in 1/2 for x. right?
1/4 equals 1/2 squared over 4 times 1/4. Right?
Oh, I was just using this one.
We're still doing this.
Yeah, that's the one that is with that one.
What? Oh. So y equals x squared. Oh.
Why
I
is
mean,
it-
either one.
Why is it the same thing, Keoni?
Because earlier I forgot what we did, but
But we got that.
yeah, we got
But
that.
if we use what you wrote there, what is in the denominator there? What is 4 times 1/4?
When?
So then you end up with 1/4.
1/4 equals 1/2 squared.
And is that true? Is
Yes.
1/2 squared 1/4?
Yes.
Okay, good.
Sasha and Keoni proved that the point 1/2, 1/4 is on the parabola, using both geometry and algebra. First, they explained that the point fits the geometric definition of a parabola because it is 1/2 unit from the focus and 1/2 unit from the directrix. Second, they verified the point 1/2, 1/4 using algebraic substitution. Because x equals 1/2, they replace the x in the equation with 1/2. Y equals 1/2 squared, which is 1/4. Next, Sasha and Keoni complete the graph of the parabola.
So why don't you just go ahead and finish plotting enough points so that you get and can fill in your parabola. You can get the shape of it.
Squared.
Now I want you to make a prediction.
Oh, okay.
We're going to now we're going to graph the parabola where p is 1/2.
Okay.
Can you just kind of show me what you think the graph will look like of the parabola where p is 1/2? Do you think, compared to this one,
Like it'll
what,
be like skinnier, like that way.
okay?
That, right?
Yeah,
Is it
do you wanna
gonna be
make a
skinnier
guess?
Or fatter?
I
I think it's going to be more
I think it'll
U.
be
Yeah.
It'll be wider.
Okay, do a, just sketch it in. Just draw, like, what do you mean wider?
So it'll be, instead of like there, it'll be like wider than it. It'll go out like that more. Not quite like that, but
Okay, and then I'll have you undo it in a minute. But
Okay.
Keoni, what do you think? What's your prediction?
I think the same thing.
Any reason behind it?
because
1/2 is greater than 1/4.
so it'll bring it out more.
Yeah.
Okay, so actually, that's what we're trying to figure out today.
Okay.
So we're gonna determine whether that relationship's correct, and then eventually we're gonna explain why.
Okay.
Sasha and Keoni predicted that as the distance from the vertex to the focus increases from p equals 1/4 to p equals 1/2, the new parabola, shown here in blue, will look wider than the red parabola. In the next episode, Sasha and Keoni test their prediction.